Alrighty, Hacksters! Welcome to Tuesday. Our guest this week is Samy Kamkar, who is an amazing hacker and founder of Openpath, a touchless access control security company. What's up, Samy? How are you?
I'm great. How are you?
Great. I'm doing okay, actually. I won't say
Yeah.
great, but got a
Yeah,
little
you
bit of
sound a little.
stuff going on there. But yeah, uh, would you like to tell us a little bit about yourself and what you do?
Yeah, sure. So I'd say at a high level, I just consider myself a reverse engineer. So I'm really just interested in how do systems work, and generally most of my life that was man-made systems, things that people created, and it started with software. How does software work, and how can I reverse engineer it? How can I understand how it operates, even if I don't necessarily have the source code? Um, and I got into hardware. So how does hardware work? How can I reverse engineer that? And I've been trying to go further and further down the stack. So I've been very interested in physics level reverse engineering, which is more really understanding
Ooh,
nature than it is man-made stuff, which is, I think, generally harder, at least for
that
me.
is fascinating. Okay, so I know that you did some stuff with phones way back in the day.
Mhm.
What did you get started with first in reverse engineering hardware?
Hardware, yeah. So, I tried to get into hardware several times over the years. So, as a reverse engineer, I was building a lot of exploits, tools for software.
Mm-hmm.
So, mechanisms to just exploit a computer remotely or over the internet or whatever it may be. And I started getting into hardware. I wanted to, and I kept reading online. How do you get into hardware? Like, what's the best thing to read? And over, I saw Art of Electronics. Um, so I got
Mm.
this book, and it was so hard for me to understand and so
Hmm.
dense. I couldn't get through like the first or second chapters. A lot of math, and I know basic math, but I dropped out of high school, so I don't know a lot of math, and that
Hmm.
was just so dense. And I tried a few times, and I just couldn't do it. And one day, someone handed me an Arduino and they said, "Hey, you can write code on this, and you can
Ah!
control stuff." And I was like, "Whoa, that's very cool!" So I got an Arduino Uno, and I wrote a few lines, and I could like turn an LED on and off. I was like, "This is awesome." And then I think I was like, well, I should make a bunch of LEDs. Like I'll get a bunch of high power LEDs, so I'll have some really bright stuff to control. And I
Mm.
tried that, and a bunch of stuff burned out. It's like,
Ah!
and then I started Googling, and I found, oh, this is why things like resistance is important to know. And I found that once I had application, it was much easier to learn something. When
Ah,
there's no
yes.
application for me, just personally, then I don't. I'm like, why do I need to know this?
Yeah. And it really helps you push through with motivation, I think.
Yeah, absolutely. I think having a fun project. So, yeah, I mean, it is a great book. So I use it as a reference now. So if I'm trying to understand how to perform
Ah,
certain
cool.
types of signal analysis. I think it's very useful. It is a great book. For me, it was just very difficult to get into, and that's just a personal
Mm.
thing.
Yeah, I
Uh,
have a hard time with textbooks too. I'm just really excited because I just noticed it that it's on the Internet Archive and you can read
oh
it for
wow,
free.
oh,
That's
it's
so
crazy.
cool.
That is cool.
So, but yeah, you found it. I also find it hard to get into textbooks sometimes, and like your application-based approach, I think, is a way that a lot of us sort of get into this.
Yeah, yeah, it makes sense. And I mean, for hardware hacking, then I guess the first real project I had is, I mean, you can actually kind of see it in, I think, over there, those
Oh,
lights.
oh
And
yeah,
this is maybe, I don't know how many years ago, many years ago, before things like WS2812Bs or WS2011,
yeah.
like Adafruit NeoPixels and
Mhm.
other RGB LEDs were widely available or inexpensive. They were RGB LEDs were very expensive back when I worked in this project. And I found after Christmas, there were some lights, Christmas lights at like a Home Depot, and it was post Christmas, so they were going really really cheap for like a 50 LED
Ah,
strip. And I could tell they're RGB because they had different modes and there was remote control. It's like, oh,
uh-huh.
this would be a fun hardware hacking project. I
Oh
wonder if I could
yeah.
modify this. And I got it, and the protocol was entirely proprietary. I couldn't find anything online for it. So that's when I started to learn how to use a logic analyzer, which is really just like a fancy term for a high speed GPIO on a microcontroller. You could technically take an Arduino and connect it as long as your voltages are okay. Then you can actually read what's happening on that signal or on that line, read the data, and then figure out, okay, well, if I take a video recording and I record this and I know there's 50 LEDs, RGB LEDs, then maybe I can figure out the protocol. And I figured out the protocol, wrote some code, and then modified it and altered the controller and just put on my own Arduino to now drive those LEDs. So that was my first like hardware hacking project. And then I got more into hacking like other things outside of maybe my own devices. that'd be more interesting.
Cool. Yeah, we talked previously, we had you on in 2016, it turns out, like 6 years ago, for another chat, which is linked in the description below if you wanna see our embarrassing younger selves. And there's one project that we were talking about then, which was OpenSesame,
Okay.
which is sort of a related one, and I wanna point out your amazing video on this because you
Oh,
kind of
cool.
walk people through that process like you were talking about, sort of decoding the signals that you're reading off of this remote.
Hmm.
Could you tell
Yeah.
us a bit about this project?
Yeah, absolutely. So that was a really fun project. That was I was really interested in how my garage door worked. I didn't know how my garage worked, and I was like, okay, I want to understand that. So I took a look at the remote control. We've seen clickers, and I'm pressing them, and the garage opens. And I opened my clicker, and there were a bunch of dip switches. Mine had 10 dip switches, binary dip
Hmm.
switches, and that was the password. It was basically a pin code. And really, 2 to the 10 is 1,024 possibilities. So it's only
Wow.
1,024 passwords. If you Now, if you have like a website and you have a 2-letter password, like 2 letters on your keyboard, well, 2 letters, let's say you have, A to Z, uppercase and lowercase, that's 26 plus 26, which is
Mm.
was that 52. And then maybe 10 digits, that's 62. 62, like if you had, yeah, let's see, 62 to the power of 2 is 3844. That's like 3 times harder. A 2-character password on a website is 3 times
Wow.
harder than my garage. Um,
Oh, no.
and I thought that was really interesting. It was like, well, do different garages have different encodings? How does it communicate? And that's when I learned a little bit more about radio frequency. And pretty much all garages these days use RF.
Mm.
Um, so, but the protocols are proprietary. So I started using software-defined radio to decode that information, and then I started using hardware radios. And then I got more into analog electronics to build my own radios from analog components. Uh, and yeah, I
Ooh.
just found there was actually a pretty cool tool. It's called the Mattel Radica GirlTech IME. It's a defunct toy, but it's this like pink pager made for teens. They no longer sell them, but sometimes you'll find them really cheap on eBay. And some
Uh-huh.
other hackers had found, like Michael Dawson and some others had found that it has a really cool chip inside. It's a SoC system on chip, which just means it's a microcontroller plus some other stuff. And that other stuff was a sub-gigahertz transceiver, which just means a chip that can transmit and receive under 1 gigahertz and under 1 gigahertz in radio. So it can
Uh-huh.
transmit and receive between maybe like 200 megahertz to like almost 1 gigahertz, so 900
Uh-huh.
something megahertz. And what that means is, like, if we've ever listened to FM radio, if you're listening to 102.7, you're listening to 102.7 megahertz. It's actually
Huh.
what. So if you go up the spectrum, then you'll hit like 200, 300, and 300 megahertz, 400 megahertz. That's where things like our garages are on, our
Mm.
cars, key fobs are on, and there's all sorts of other stuff going on in that frequency range. And
And
that
because
chip,
those bands are allocated, right? Like, the FCC controls which, types of protocols and which types of devices are in each type of band, so you can kind of like, that any garage door opener is gonna be in a certain band.
yeah, exactly. Yeah, the U.S. In the U.S., the FCC
In the US,
controls what
right?
you can transmit. Yeah, and then in other countries like uh, yeah, like I think I, I'm trying to even remember the names, not CE, but I don't know. There's other radio companies. But the nice thing is when you actually look at the back of devices, at least in the US, they will have an
Right.
FCC ID if they transmit, and then you can look that up
Oh.
publicly and
Huh.
then find the frequencies that you suggested, like to actually see what this thing transmits on, assuming it's legit, assuming it actually passed FCC. Some devices might actually illegally not do that.
Mm.
But there's other ways. You can look at the antenna. You can use a software defined radio and scan the spectrum, and look for and a way that I think about RF is I just think of it as sound, but
Mhm.
instead of using air pressure waves, it's its own thing. It's light, right?
Right,
Technically it's
yeah.
light.
Yeah.
Yeah, yeah.
Oh, yeah, it reminds me of, there's these little HexBug robots that have their own little remote controls and stuff, and they're like,
Okay,
and, I tried to hack those back in the day by, like, simply clipping a couple of leads connected to an audio plug,
okay.
uh, to the transmitting IR LED leads, and
Oh,
then, like,
nice.
recording with a sound recorder app what came off of those. I wasn't able to get it working. I think that there was something with, like, the bit rate that it was encoding at when I was recording, but I really wanted to just be able to, like, record what was coming off the remote as, like, an audio file and then, like, play it back through my own LED. Sadly, it didn't quite work out, but someday maybe.
Yeah,
But
well, that's a great idea. That's a really cool project. I mean,
super
it
low
might.
tech.
No, I mean, why? Yeah, we should be as low tech as we can, right? Let's simplify
Mm.
things, and it's really cool because the sound card itself is really just an analog to digital converter, right? An ADC.
Mm.
So as long as your voltage ranges are okay and you're within the maximum frequency that your that the sound card can record, you can like record data off anything. So I think that's actually a really cool idea. You might just need like a couple of additional passive components to get the voltage range okay.
Mm.
But yeah, and then the Open Sesame project, I guess I was also looking, okay, well, I can now brute force the pins on garages. And then I found another attack. This was a new attack I developed.
Ooh.
And it's basically, instead of even having to brute force, which would take like 30 minutes, and you don't want to sit outside, like if you're a criminal, you don't want to sit outside for 30 minutes. I
Yeah.
think it's really interesting. Is there some way that you can speed up that communication? You
Mm.
can't really speed up how fast you send it because the receiver in the garage is a receiver that's listening for that RF that is listening at a certain rate.
Right.
But I wondered, like, if I send a 10-bit code that's wrong, it'll probably ignore it. And then I send another 10-bit code that'll ignore it. But I started playing around. What if I send a 1-bit and then I sent my correct 10-bit code? And I found that worked, which means that it's actually using something called a bit shift register, where if I sent 11 bits
Uh-huh.
and it's looking for a 10-bit code, it takes in the first 10 bits and says, this is wrong. Instead of throwing out all the 10 bits, it only shifts out 1 bit and then pulls in the next bit. So I sent
Oh,
11 bits and tested 2 separate 10-bit codes.
yeah.
So then I was looking around. There must be some type of sequence, or I was hoping there was some algorithm that would allow me to essentially overlap all the possible
Yeah.
codes as efficiently as possible, as dense as possible. And there was a mathematician named De Bruyne who had created an algorithm, a formula for doing this, and I was able to use that.
That's what
And
this
that
is.
means, yeah, but yeah, this is a simple demonstration using 3 bits. And interestingly, the more bits you have, the longer the code is, the more densely packed you can actually pack it. So here we're saving for like a 3-bit, for every 3-bit code, you only need to send 10 bits, which is a couple, you save, instead of, I guess, what is it, 24 bits, you save like more than 50%. But once I got to like 12 bits, which is what most garages are, max, then I got to like 95, 98% density coding. So I was
Dang.
saving, instead of 30 minutes, it took 8 seconds
Oh
to
my
basically unlock
gosh.
any garage, any
Wait,
fixed code garage.
so you weren't even limited to 11 bits. You could send like 95 bits in a row and it would like
Exactly.
continually shift them through. And
Exactly.
oh my
Yep.
gosh, that seems so insecure. I feel like you must have these moments all the time where you're just like, oh, well, maybe you're over it by now, like you've been doing this for so long. But like I feel like, people in the security company are always just like, when you realize how like insecure the basic things that we like depend on, like my bike, well, how is it being protected?
I mean, yeah, it feels great to find that kind of stuff. It's very magical, and it's not really, I've done this stuff long enough. I know security is hard. Like it's obvious. People might say something is obvious, but it's never obvious until you know, right? It's like hindsight is
Yeah,
twenty
yeah,
twenty. So security is difficult. So I definitely also have a ton of respect for people who do build security and build products. And
yeah, yeah, yeah.
I build products myself, and I know how challenging that can be. But it's always fun to see how can we make things more efficient. And I think people should understand, should have the option to understand how their technology works. So I like sort of lifting that veil and showing people that actually you have a lot more control over your environment than you think.
Yeah, and we have a couple comments from Uswint who says, "Big fan, love the way you explain rolling code and car keys." And if you have to name one hardware that a beginner should purchase to enjoy RF and ethical hacking, what would it be at?
Sure. So for RF, I think there's 2 tools that I would suggest. One, and depending really on your price range,
Mm,
one would be HackRF. It's a few $100s for a software-defined radio. It's very powerful for its price. And I'm really interested in low-price technology, so I'll
mm.
invest my own money in high-price stuff, understand how stuff works, and then figure out a way that I can find lower-cost tools so that I can share that with other people that they can use and perform the same types of things.
Mhm.
Um, and HackRF is awesome because it can transmit and receive from like something like a megahertz to 6 gigahertz,
Huh.
which covers all sorts of things. So that includes protocols, bands like Wi-Fi, Bluetooth, both 5.8 5 gigahertz and 2.4 gigahertz Wi-Fi. You may not be able to transmit at the speed or hop at the speed unless you write firmware, but you can still see some packets. And then all sorts of low frequency stuff, so like FM radio, like we said earlier, like 102.7 megahertz or whatever. Cars, you might be able to do GPS with it. Now, if you don't want to invest a few $100s up front, then you can get something like a $10 or $20 US software-defined radio called RTL SDR. So yeah, these are really cool. These are actually made for, back when we had analog air TV, these were made for that. So it would basically sniff the whatever UHF, ultra high frequency TV signals from the air and then run it through your computer. But your computer's software did the decoding. So someone figured out that it was actually the software doing the decoding, not the hardware. And all the hardware was doing was sampling the RF and then sending it as they're called IQ samples, which is really just like the amplitude and the phase. Amplitude just means volume. So I think of it as sound. Like, I think of amplitude as volume, and I think of the phase. The phase is where you are in, say, a sine wave. If you're sending a 100 megahertz sine wave, where you are in that. And that really is just a wideband receiver. Well, not wideband, but it has a wide bandwidth. So you can change, or wide operating range. So you can change what frequency you can. I want to listen to 100 megahertz, or I want to listen to 1 gigahertz. And I think RTL SDR goes up to like 1.7, maybe 2 gigahertz, depending on the type you get, the tuner you get. But it receives only, so you can't transmit with it. But it's for $20, $10, I think it's very powerful for what it does, and is a great way to get into it. And there's plenty of software out there. GNU Radio is an amazing signal processing platform. GQRX is software for seeing the spectrum, so you can visualize the spectrum, like a waterfall plot, so you can just see what's happening. I think the more we see, like the more stuff we just don't realize. I think that's the really cool stuff. Like there's there's a cool subreddit, and the name escapes me. It's something like Signal ID or Signal Identification or something like that. It's just people who listen to radio and are monitoring the spectrum, and they'll be like, what is this signal? Like, they're not sure what it is. It's modulated a certain way. It's encoded a certain way. It looks unique. Sometimes it's a satellite. Sometimes it's a weather station. Sometimes it's just noise from some device in someone's home. And I mean, there's all sorts of other cool stuff with the radio. Like there's someone named, I believe it's Windy Tan. I think that might be her Twitter name, or Una Tan. And she's done a lot of cool radio stuff. And I think she was doing some signal analysis of like maybe a helicopter or something. I think it was a YouTube video. I'm probably not entirely accurate, but we can look this up. And she was, it's like a YouTube video or something. And she was listening to the audio, and there was some signal in it. You could hear some noise, some interference, like while you're hearing the audio. And she extracted that, she filtered that out, and then was trying to decode what it was. And actually, I believe found that it was like some GPS information. So you can actually track where that helicopter was going.
Whoa!
So there's all sorts of, and that kind of stuff actually happens. Now, if you take that further into security, there's research out there that has demonstrated that, let's say there's certain devices out there where it's encrypting something. Let's say you have a microcontroller and it's doing some encryption operation, but it's also transmitting over Bluetooth. If those are happening in parallel, and often there will be a hardware accelerator that's performing some cryptographic operations on a device. Think about maybe like a Bitcoin wallet or cryptocurrency wallet, and it's transmitting at the same time. Well, often there's noise. There's constantly noise. That's why we use digital signals. That's why an Arduino is like 5 volts is high, or 3.3 volts is high. And that's because it's not always going to be 3.3 volts. It might be 3.2 or 3 or 3.4. And we don't care. We just want to make sure that we can turn on a transistor, and that's like above 2.4 volts or something like that. But if you look, instead of looking at the digital signal, if you look at the analog signal, if you actually measure the analog signal, you will see something. You'll see noise. And that noise is information coming from other parts of the computer or the microcontroller. So that could be the encryption key. That could be, things that are basically like, all this stuff like RF and noise. This is all really interesting physics. And sometimes it's intentional, and oftentimes it's unintentional. So there's constantly unintentional noise, which is why we even have digital signals. So you can actually like extract things like keys just from listening to radio. You can extract secrets like passwords from listening to sound. Like our computers, when we're encrypting something, they're producing sound. We don't hear them because often it's ultrasound. But if you've ever heard like maybe a high pitched whine from something like a power supply on your computer, or a power supply for anything, sometimes I hear high pitched buzzing, and I hate like high pitched sounds.
I have the same thing. Yeah.
Yeah, exactly. So I'm always replacing the fans in all of my devices. So I take my oscilloscope and like whatever CNC and everything. I'm gonna replace the fans with like knock to a really low noise fans. But then if I hear high pitched buzzing, I like opened a power supply and found out what it was. And usually it's either like an inductor. Inductor is really just a coil of wire. And what's happening is whenever there's current that goes through any wire or conductor, there's a perpendicular magnetic field. And that's how like an electromagnet works. You just put current through a coil, and the more it turns, the more that's additive a magnetic field that's perpendicular to that coil. So what's interesting is with an inductor, like there will be back and forth noise. It'll be like AC, and that noise is due to the amount of power the system is using. And that magnetic field is now causing this magnetostrictive effect. So something is moving inside and producing that noise, or it's a capacitor. And the capacitor has like a piezoelectric effect, so it's physically moving and there's some high-pitched noise. But what's really interesting is that the amount of power that's being pulled is dependent on the amount of power required for the instructions that the computer is running. So if the CPU is doing an addition or a multiplication or modulo, those all use a different number of transistors and thus uses a different amount of total power. If you measure that with something like an oscilloscope or an FPGA and ADC, then you can begin to see, oh, this is using more power for this moment and less power. And if you start looking at that as the pattern, you might say, oh, well, I assume that this is encrypting something because whatever, it's a Bitcoin wallet or something. And it now, maybe I see something like a pattern of 2048 sequences, and some are higher, maybe higher amplitude, or maybe some are longer time. So maybe there's more operations happening in there, but there is a pattern. And that pattern might give you information like 2048 is the bit size of an RSA key. So you can then begin to deduce, oh, this is actually a key that's being used because the different instructions, it's using like modulo plus multiplication versus just multiplication. Then I can calculate, oh, this is probably a 1 versus 0. And now you can extract that key from the sound, like literally by listening to it. Maybe not with your ears, but with a device like a phone.
Incredible. There's a really interesting, I haven't actually read this yet, but there's just been a crack by Joe Grand, who cracked a hardware crypto wallet, and I'm not sure exactly how he did it, so it's a little bit off topic, but you reminded me of it, and I can't wait to like read this article about it. We have some lovely feedback from someone who says, "Greetings from the Netherlands. You're still the greatest coding guy around."
Awesome. Oh yeah, Joe Grand's awesome. I think he was using Chip Whisper from Colin O'Flynn's an awesome FPGA toolkit for doing side channel analysis and fault injection. And just at a high level, side channel analysis, that just means listening to stuff like, instead of exploiting a system, like someone builds a computer and you try to exploit what's inside of the computer, well, instead, a side channel would be something that we don't even expect the computer to emit. For example, sound, right? So that would be the sound that it doesn't intend for it to produce that sound. This is a property of physics that as a side effect. So that would be side channel versus fault injection, where you're trying to intentionally induce a fault into a system. So if you have something like an Arduino Uno and you write some firmware and you're like, okay, this is cool, I'm going to release this as a product. I'll take the microcontroller on the Arduino, which is like an Atmega 328P. I'll put that in my product. I'll write I have my firmware that I wrote for it. And now that I'm putting it in production, I don't want anyone to download that firmware. Maybe I have some secret material in there. Maybe it's decrypting something, or I just don't want someone to steal it. So the Atmega and many other microcontrollers have some sort of boot protection. You can enable a flag that says, don't allow anyone, if they hook up a debugger, don't allow them to access the flash, don't allow them to access the memory. All they can do is erase everything and then start over from scratch. However, fault injection would be a mechanism where you can trick that chip into believing that that flag is not set. And you can do that in interesting ways. So, for example, in Chip Whisper is an amazing tool that allows you to do that, where you can say, when you're booting up your chip, when it's starting up, it's running, all of our chips have a clock. So these microcontrollers every time there's let's say a falling clock edge, a bunch of transistors will do something. They'll execute an instruction. And that instruction takes power. So one way to perform fault injection is you'll say, I will remove power for just one instruction cycle. So if you're running at 16 megahertz, that's, I don't know how many nanoseconds or microseconds per instruction,
Right.
but let's assume it's 1 microsecond. That's not accurate, but let's assume that for a moment.
Sure.
We can pull power down from 5 volts. Let's assume it requires the microcontroller requires 5 volts. We'll pull it down to like 1 volt, enough that it doesn't reset, but it does attempt to perform the operation. And now it's maybe trying to access some bit in memory to say, am I in production when I shouldn't allow the debugger? And
Right.
it sees that bit, it's there, and it tries to transmit it, but it doesn't have enough voltage for the transistors to actually, let's say, for an NPN transistor gate to be enabled. It doesn't hit the minimum voltage level on that gate. So it can't even transmit that. So it attempts to, it thinks it did, but it didn't. And now you return the voltage. Now you don't know which instruction it is, but thanks to computers, we can say, all right, for 1 microsecond, remove the power, put it back, and then try to get in debug mode. If that fails, pull down reset the chip, put reset back to high, and let's try again, but let's wait an instruction. Let's wait 1 microsecond, and then pull down, and let's reset, and keep doing it until we get into debugger. And you'll actually end up successfully performing this attack, and you will actually bypass the debugger protection mechanism and be able to access the flash, dump the flash, investigate all the memory, run any instructions you want, extract any secrets like private keys, pins, passwords, etc. from devices. Or you might be able to do other things, like if you have something like a PlayStation or Xbox and you want to run your own code on it. They don't want you to do that, right? They want you to purchase the low-cost, powerful computing platform and then purchase the games. And the games is how they really make money.
The razor blade model.
Razor, yeah, that's funny.
Sort of. I don't know. It's a bit more complex than that, obviously.
I mean, printer is another good example.
Printers and ink, yeah.
Right, printers and ink. It's like cheaper for me to just buy a new printer every time.
I know, right? Oh, it's horrible. Encouraging waste. I feel like what you do, reverse engineering and penetration testing and all this stuff, is very closely tied to the right to repair movement, and this idea that if you own a device, you should own it and be able to do what you want with it. And it's something that's like huge, obviously, but especially right now when you have things like, this absurd model where like it's not worth it to fix things sometimes because monetarily, and then also you're actively discouraged by the companies. But there's a bunch of stuff going on in legislation right now where like their right to repair stuff is so cool.
Yeah, I think it's interesting, and I feel I try to definitely think of both sides here, where I think that I think a company should have the option to sell in whatever business model they want. Like if they want to do the expensive ink, they can do that. Because I wouldn't like if I made something and someone told me I had to sell it at a certain cost or I had to do it a certain way. But I also think it should absolutely in no way be illegal as a consumer buying it to modify it or want to repair it or modify it in my own way. And that's that's the things that I definitely do not agree with. There are some companies that have attempted to tell the U.S. Copyright Office, like GM and John Deere, they've been trying to get the Copyright Office to say it should be illegal for you, like criminally liable for you to, let's say, modify or repair your own vehicle without taking it to someone who is certified, for example. That does not make sense to me. I think it's fine if they want to make it difficult, right? And I think it's fine if they want to say you're out of warranty for modifying your own thing.
Like that makes sense to me.
Yeah, but I don't think it should ever be illegal, as you said, for us to if we own it. They're trying to say we don't own it. We are purchasing a license to operate it, and that's not what I believe ownership should mean. I think it shouldn't be illegal. I think whatever the business model they want, that's fine, but we shouldn't be criminals for playing with the things with the
toys that we bought.
Yeah, absolutely.
So we're at about our halfway mark, and this seems like a good spot to do our rapid round. We have a Spark Fun rapid round series of rapid fire questions about rapid prototyping, but largely about whatever, and also your business. So are you ready to play? I'm gonna hit the big red button. All right. 1, 2, 3, go. Okay, so what was your first computer?
It was a Packard Bell 46. Oh! Keep going.
Talk about hacking. Okay, crowdfunding or private investment?
Oh man, I mean that depends on what you want to do. If you do crowdfunding, then you're at the end of the day.
There's an extra time.
Nice. At the end of the day, I think of it like I also have a boss, right? Is that boss the investors? Is that boss all the consumer, the users? And you have to there's a combination there. Crowdfunding, Uh,
Okay, I'm gonna bring you back to that one later.
depends on the project.
Best snack on a hardware install day.
Uh,
What keeps you going?
Monster.
Next team member you would hire for your company.
Next team member.
Mhm.
I work with really amazing team with a really amazing team. But I love people in the community, in the hardware, software hacking community, people that put stuff out. It doesn't matter how high level, low level it is. I love that people who are trying to create stuff and just share with the world.
Awesome.
Those are the people I love to work with.
Yes. Favorite musical artist right now?
Musical artist. Odessa just released a new song today, and I listened to that.
Ooh.
I like that. Yeah.
I'll check that out. Sweet. We're out of time. Sorry
Okay.
about the whole thing.
Oh, it's okay. It's hilarious.
Oh, we got some good meaty stuff. I also have one more question that I actually
Yeah,
want to
of
ask
course.
anyway. And also, it actually ties into I downloaded from the library this book, Tools of Titans by Tim Ferriss,
Oh,
and you
cool.
have shared a lot of really interesting stuff about tools that you use for hardware hacking and
Yeah.
for learning about security and stuff too. You share a lot of tools, more software focused, but if y'all are interested, there's a lot of interesting stuff in there about, you know, tools and learning resources for security, and it's really interesting. And I was wondering, is there an organizational tool or resource that you, as a hardware founder, can't live without, or just as a business founder?
Um, I'm sorry, you said a hardware organizational tool?
It doesn't have to be about hardware, but you as a founder, I was wondering if there's a hardware or software like tool that you can't live without.
Uh, I don't know if there's any specific tool. I mean, project management is always important.
Mm.
And fortunately, I work with people who are way better at that than me. Fortunately, I work with people who are better at everything than me. So that's
It's
really
the way to
great.
be.
But just being able to find those people is really important. I think that's probably the most important thing. And I don't even know if
Ooh.
that's the tool. I don't think there's maybe any tool there. I think that's just trying to find maybe like-minded people, and people who also think differently so that they can challenge you. I love to be challenged. Like I want people to tell
Mm.
me I'm wrong, so I can learn and I can improve. And I will challenge people. Like, how can we make the best product possible for the people who like to use who want to use something. I think that's really cool. So yeah, I don't think there's any maybe software or hardware. I think it's more about who are the people you are going to work with.
Yeah.
Because I'm really fortunate to work with my co-founders. They're amazing, and all the other team that we got to that have joined us. I think that's
So
the
then,
most important thing.
so I think we can sort of rotate this around a little bit. How do you find those people?
Sure. The A lot of it is over time. I mean, I'm a nerd, right? So I'm not. I don't go out a lot. I'm behind a computer. I'm in my workshop working on stuff. But there are places that I do go. So I live in Los Angeles in West Hollywood, and Crash Space is
Oh
a
yeah.
hacker space, makerspace. So I started going there many years ago and started learning from people. And people were so friendly, and they would teach me things like, because I would come in and ask about like LEDs and electronics and 3D printing and laser cutting, and people would just like happily show me and teach me how to use these things. And I have met so many amazing people there, and I feel like just at our company Openpath, we probably at least work with 10 or 15 people who've come out of just Crash Space directly. Um, and otherwise, other places are just meetups. So I'll go to various software or hardware or hackathons and just
I know we've
meet
hung out
people.
at SuperCon, for example, another one
SuperCon,
in
yeah,
LA.
absolutely. And I'm not going to hire people. I'm going to hang out, right? This is
Uh-huh.
just really fun for me. But those are the types of people that I really love to work with, and I think they have at least a similar ethos to me, which is, I love to share information, and I'm really excited about the kind of stuff that I want to spend my time working on things I'm excited about, and
Yeah.
finding that is really cool.
I think that's really compelling too, like, when people, have that same kind of there's a lot of people like that in our community, and I think that we're partly drawn to it because of this, like, curiosity about hardware and stuff. Because 'cause we're not necessarily taught this in school. It's
Right.
something that everyone has kind of sought out for themselves, and so, yeah, it's an amazing community full of, and that is the type of person that you wanna work with. It makes it interesting, right? Yeah. Oh,
Yeah.
amazing. So let's talk about your company, Openpath. We haven't brought this up
Sure.
yet. Can you tell us about what Openpath is and
Yeah, absolutely. So at a high level, we started a few years ago, and we created a mobile and cloud-based, basically touchless physical access control system. All that means is we're focused towards business. So if you go into business and you've used RFID cards to get into buildings, we found, I mean, they're just like a huge pain. I had a previous company many years ago. We used the RFID cards. All of my co-founders have had companies in the past, and they've had RFID cards, and that was kind of just a constant hassle that we've dealt with. And also about maybe 10 years ago, I released a bunch of software as part of the Proxmark 3 penetration testing kit. It's an RFID penetration testing tool. And I released a bunch of software and firmware in there that allows people to literally walk by people and steal their RFID credentials. And you can clone them, you can replay them, you can perform other types of attacks. And I've done a lot of attacks in the RFID field. And so the Proxmark 3 allows and I found that most businesses continue to use these types of RFID cards that are really insecure. And there are some secure ones, but architecturally, the way these systems work is really, really insecure. So we created a new type of system where you have a reader. I'll actually show you the newest reader that we just launched, which is the video reader. I'll pull the plastic off here.
So satisfying.
Yeah, so this guy basically sits on the wall. This has a camera, so kind of like a ring, but you can use RFID cards, and we sell encrypted RFID cards called Justfire EV3. And you can also use your phone. And that's actually the coolest part. You just have your phone in your pocket and you have our app. You never have to open the app. It's sitting in the background and it communicates with the reader. And it's actually encrypted end to end. So not to the reader, it's from your phone through the reader, through the wiring, all the way back to a secure access panel. We also built that hardware, firmware, software, cloud, mobile apps. We built virtually everything. And it will then authenticate over TLS. So we're actually doing TLS over Bluetooth Low Energy. And we created a cryptographic protocol, our own protocol that's basically open, using open standards like TLS, which is what you'd use on secure websites, in order to unlock. And you just have the phone in your pocket and you can just walk in. So that's the high level convenience factor, and it's just very easy to use for companies.
And it's interesting that you mentioned that it's all open because, I hear conflicting things like, you should never roll your own security. Obviously, this is exactly what you do with your life. So that kind of
it's interesting. Yeah, I mean, you have to think about that, right? When people say don't roll your own crypto, and so someone has to, right?
Someone has
At the end of the day,
to.
someone has to. So
you're not allowed to use it because you made it. Or something.
Yeah. Now, we really do agree. We want to use things that are already well vetted and have a lot of people already trying to attack it, and that's why we chose TLS as the cryptographic layer, where nothing else, no other system is using that. We don't store any secret keys or secret material in the reader itself. This is basically we call it a smart reader, but technically on the cryptographic area, it's dumb. It doesn't know how to decrypt anything. So even if it were modified or altered in any way, it can't decrypt. It's actually just passing it through, kind of like a hop on the internet when you're going to your bank, right? The random router on the internet can't decrypt your traffic either because they don't know the key to that communication.
Right.
And we use public key cryptography, so public-private keys versus the rest of this industry, which uses symmetric or the same key. So if you hack one device, let's say some reader or phone or something, and you get that key, you now have the key for kind of everything.
Yeah, but instead you have a different one for each. And also, it seems like the open source nature of the protocol helps with this because isn't that a great way to sort of get people to test what you're doing? And that way it's not just necessarily your expertise and your abilities and experience, but it's the whole community is able to sort of test it for you.
Yeah, so the TLS protocol, that's entirely open. We have a bunch of stuff on. We actually have some projects on our GitHub. A bunch of stuff is not open source. So like a cloud backend is not open source. I think our firmware is not open source. But we also do take a very, I'd say, open stance when it comes to security. We want people to attack our stuff, so we don't try to protect things. A lot of people try to make it hard. I'll give it an interesting example. There's the old cards are called MyFair Classic. The company that created NXP, they tried to make it difficult to understand what the protocol, what the cryptographic protocol was. And running in cryptography, there's an algorithm, there's a key. It's generally how it works. And my opinion is that it's best to keep the key secret, but not the protocol. And they kept the protocol secret too. And because it was implemented in hardware, the problem became that it became ubiquitous, became used everywhere. So buses use it, metro,
Yeah, yeah,
all
yeah.
over the world. Every hotel I've ever been to uses MyFair. And because it was hard, they made it hard to understand the protocol and reverse engineer what that is. It means they lasted longer before anyone understood how it worked. But once people did reverse engineer it many years later, well, then it was all over, right?
Yeah.
Millions and there's like billions of these cards out there. And finally, someone reverse engineered it. A few people looked at it, Kristen Knoll and some others, and they found a vulnerability. And now all those cards are now vulnerable, and they have to create new protocols. Um, but instead, if like it's okay, things will get hacked. So the more open you can be, the more you can actually use open standards. Then, if it does get hacked, at least it'll happen soon, right?
Yeah.
And the people that are harmed you minimize that as much as possible.
Yeah, it doesn't get too embedded before a fix is
Exactly,
possible.
exactly.
How do you feel about quantum computing? Are you afraid of it, or like, are you excited about it, or do you think that it's all a big boogeyman and like it's not going to really like change that much?
No, I think it's definitely going to be very powerful in certain ways. So, I am some of my personal projects right now are focused on quantum mechanics,
Ooh,
not quantum computing. I'm doing a little bit. IBM has an amazing thing called the quantum experience. So you can use their quantum computers today for free, and you can actually write quantum assembly, or you can
no
use
way!
Qiskit. They have a Python interface. They also have a nice web graphical interface.
Oh my gosh!
Um, and they have an amazing, like really amazing documentation, QISKIT, and they teach you like starting from scratch how to understand some of the quantum operations, and it's really interesting because it's just new. It's really hard to understand or like think the way that things work, because there's things like superposition and entanglement. There's things like phase kickback, where you're modifying one bit and that actually has a probability of modifying another bit.
What?
It's really weird stuff, but it's really cool. And there's algorithms out there that people are afraid of, like Shor's algorithm, or people are excited about, like Shor's algorithm. That can crack certain types of like asymmetric cryptography, things like RSA.
Yeah.
We don't have the power today. Supposedly, some of these companies like IBM and Google will probably have that capability. Hope maybe in the next few years, maybe not. There's also technologies like post-quantum crypto that are coming to try to prevent those types of attacks. But what's really cool is, and what I think is really exciting, is that this is a really this area is accelerating, just quantum computing by itself, and everything is free. Like everything, like IBM wants people to learn. People
Wow.
want because it's a new way of thinking. That it's a way people don't think today. We just don't think about this stuff because we don't experience it in normal day life. We
Yeah.
don't experience quantum superpositions and entanglement in normal day life. And that means there are applications that we just haven't thought of because it's hard to think of it. It's just hard to, like, sometimes you think about a problem for a while and you come up with a solution, sometimes in your sleep. Well, that's using knowledge that you've had your entire life or that you've been learning over years. But this is like knowledge that's kind of very new, even though quantum has been around for, I don't know, our knowledge in quantum has been around for, I don't know, 50 years or something, and increasing every year, of course. So I'm very interested in that because I also think I'm interested in applications outside of the computers themselves, but I have been using
Mm.
their computers just to test stuff. Um,
Oh, so
and,
cool.
and yeah,
Uh,
I think light itself is really interesting because you can do very cool things with light. Like you can take a single photon and you can split it in two, and one is only ever detectable, another one is not, and that's a superposition. But
mm,
that one that is not detectable, literally not detectable by anything, unless it interferes with light again, then it can inform us of something. There's a very cool
yeah.
experiment called the quantum, I think, bomb tester experiment that people can look up. And that's a demonstration of what this can do. It can inform us of information. It can inform us of something in a path without light ever traversing that path. So, like,
Wow.
imagine knowing what's inside of a room by sending light without ever sending light in that room because it was dark.
And it's related to entanglement because of the two photons that have been split, or?
Yeah, good question. In this, it's the quantum. I'd say the feature would be superposition.
Oh, okay.
So there's no entanglement necessary here. What happens is a single photon will hit something like a beam splitter or a slit. There's the double slit experiment.
Right.
Is a great example of this. The initial double slit experiment was if I have like, I think you know this, but if you have, let's say, a wall and two slits, if you shine a flashlight like or a laser at that, you'd expect to see just two lines that like go through this two slits, and then you'd see two lines. But instead, we see interference pattern. And instead, like one way to think of it is with water. If you had a lake and there was just that lake wasn't moving, and then you had a dam with two slits in the dam, and you just created a wave, and that wave went out, round to the two slits, two new waves come out, and those waves will then interfere with each other, and you'll have these peaks and troughs. And that's exactly what you see with light when you put it through two slits. Now, the absolutely incredible
That's why
thing
I know
is,
it's a wave in
what's
some
that
ways.
exactly? Yeah, in that scenario, it's a wave. But the amazing thing is, once technology got a little better, people tested this double slit experiment with single photons, one photon at a time. And it's all what happened. Like, what would go through both slits, which slit would go through, and what would they see on the other end? And they would only ever see one photon, one dot of light. But every time they sent it, they'd expect to see it on one slit or the other, but they'd actually see it. They see the same interference pattern, like if they just recorded where the dots would go. And they'd see either go through one slit or the other slit or somewhere else. Like it would just keep producing the interference pattern. And they would see the same exact interference pattern as if they sent a laser through. And really what that told them was that that light is interfering with itself. It's splitting and then interfering with itself.
Yeah.
And that reveals information about the path of that. And that's a superposition. That's when it actually splits in two, and you have a photon of light and a superposition of it.
I love it.
Yeah, it's really, really crazy. It's something we don't experience, at a more of a macro level. But because it's so crazy, it means there's so many applications that any of us can come up with if we just start thinking about this kind of stuff.
Amazing. I love where this is going. Since we're sort of coming to the end of our time, I'd love to bring it down to earth a little bit more.
Sure.
I mean, actually, all this is intrinsically part of our earth, and that's what's so cool about it. But there's some more cool stuff that we can talk about, including this thing that you actually have with you today, which is this mag spoof device. And I think this is such a cool demo here, where like those magnetic stripes are literally just like stripes of magnet. Yeah, tell us about this this mag spoof project.
Yeah, I was just playing with credit cards. I want to know how credit cards work, and I know they have mag stripes on them. So I wondered, is that like actually magnetic? I wasn't really sure. I took like a paper clip and I tried to pick up a paper clip and I couldn't. And then I was like, well, magnets, they pick up iron, so maybe I can get some really small iron particles. And I got this bag of iron oxide, and I put my credit card in, and you can actually see I took a little video, a little animated GIF. And you can see the bits, and those are basically strips of ones and zeros. And on the page itself, there's more details of how that all works and high-res image of it. And you can, with the naked eye, you can actually see the ones and zeros. You can scroll down a little further, and then scroll down a little further, and I think there's like a full image. There you go.
Oh my gosh.
So you can just read my credit card number off that, and then for up in the page, I show what those bits mean and how you can actually calculate what all that means. And then I thought, all right, well, can I modify this card? Like, I saw these bits, I wasn't sure what they were. And then I found that they did stuff like, if you swipe your credit card somewhere, and if you have a credit card with a chip, but you swipe the mag stripe, it'll say, this is a chip card. I need to insert your chip. It's not going to work. And I was like wondering, how does it know that this is a chip card? Because I had another card that didn't have a chip, and I swiped the mag stripe and that worked fine. So then I realized the mag stripe must have information of whether that chip is in there or not. So I took a bunch of cards, and then I figured out, oh, this bit means there's a chip or not chip. So if I were, let's say, a criminal and I stole someone's credit card online, could I then generate a credit card and go use it? And as long as I disable the chip bit, I could do that. So then I thought, okay, you can get a mag stripe writer, but I thought, because it's magnetic, couldn't I just take an electromagnet, a coil of wire, like we talked about earlier, an inductor? And couldn't I just put electricity through it with like an Arduino? And I used an ATtiny in this mag spoof project. And I can just turn it on or off to basically produce a magnetic field on and off. And then I can, as if I'm swiping, because when you're swiping, you're just sending those ones and zeros of magnetism to the magnetic read head inside the point of sale system.
Like
so really, sorry?
Just like a cassette tape.
Yeah, exactly.
Only it's more digital, not analog.
But it's just information encoded in there. And So there's nothing preventing you from actually wirelessly transmitting a magnetic stripe. Not with NFC, not with RFID, not like Apple Pay or Google Wallet. It's really you can produce a magnetic field and send that information. And then I found some vulnerability in the way certain credit cards worked. I found if you like cancel a card, the new card you get, it actually follows a pattern. I first figured out that pattern, and then I found that if I were an attacker, if I stole your card and just the card number, I can now use MagSpoof. I can use your card. I can charge it for a bunch of stuff, and then as soon as you cancel it and I see it stops working, I can press a button and generate the next card number.
Oh my gosh!
And you're still waiting for it in the mail. You don't have it yet, and I'm already using it.
Well, but, I mean, is that why they put the thing in there where you have to like call them to activate it first, or use it first at an ATM?
Sometimes, but
Sometimes
like
I've
less
lost
and
my
less.
card enough times that I'm like familiar with this. So
Yeah, less and less we don't have to do that. And another thing to note is that if they do that,
Oh,
like I
man.
haven't had to do that in a long time.
Ah.
The sticker often says that, but I haven't had to. And one thing I've also found, I mean, another thing to note is, well, typically they just validate your phone number, right? The phone number you're calling from. But caller ID, you can actually spoof that. You can set that to anything you want. So you can use like a voice over IP provider, and you can set your caller ID number. It's actually like an HTTP header. If you use like a SIP carrier, SIP is just a voice over IP protocol. You can then set your caller ID to whatever you want, and you can call them and then activate it if you're an attacker. So these things are like, it's a bunch of fundamentally simple protocols or simpler protocols that don't really have a lot of security there. So a motivated attacker could mess with this stuff. And then this is actually someone had taken my schematic and created a awesome PC board just to make it a single board device. So this is actually just a big coil in here on the PCB itself as a trace. So you can go and simulate and test things. And you can do this for like hotel key cards and all sorts of things.
So is there just like a button on there that like?
Yeah, exactly. Just like a button on there. And then you can program it. My firmware is on GitHub. Just to see how do these things work and how can we mess with them. And you can get a credit card reader, like a Stripe or something, and see like what other things are possible.
Yeah, I gotta follow you on GitHub because the first thing you see when you go on your GitHub is this massive, cool project where you're doing this visualization of orbits. And what's going on here?
Yeah, so originally I found this on Wikipedia, and I found that it was an SVG, and I was actually really interested in SVG because SVG is like a scalable vector graphic format, I believe. And you can make animations because really SVG is like a compilation of a bunch of other protocol or a bunch of other, I'd say, formats. So you can use, it's all in XML, and then you can inject things like JavaScript or HTML or CSS. So you can style this stuff. And now on the web, when like on GitHub, for example, you can't, that image didn't work at all. Like it was using all sorts of technology that if you use an SVG image, you're limited to what you can do. But if you use an SVG embed, then you can take advantage of all this stuff. Now, most people won't let you embed SVGs on their website like GitHub, because then you could execute JavaScript and they don't want you executing JavaScript. But I then started working on it and found that I could actually, rewrite it and make everything work as a pure SVG using built-in SVG animation code. And then, yeah, I've been interested in some space stuff, and there's some pretty cool projects out there. There's actually a Kickstarter where you can send your own little femto satellite, just a really small circuit board you can send it to space. Let me just find the project.
Oh, please. Yeah. I think there's something in the air right now. I also got really into like orbits and things and identifying stars and like trying to figure out like I want to create a 13-month calendar based on the different orbits and
awesome.
Oh my gosh.
Yeah, that'd be really cool.
And Joey Castillo with the Sensor Watch has been doing some stuff around astronomy. I'd love to hear about this.
Oh, cool. So AMBASAT, A-M-B-A-S-A-T. That's the project where basically someone is creating a CubeSat to then launch all these smaller satellites, and they'll all communicate. The idea is they'll all communicate over LoRa. So it's a long-range protocol. Gosh. And there'll be a mesh, and then they'll talk to LoRa transceivers sitting on people's roofs. So I've actually set up a LoRa transceiver on my roof, and I'm actually messing with LoRaWAN. And it's actually kind of cool just how I actually communicate with my systems on the roof. So I'm in a condo building, and there's someone who lives above me a couple floors. But I found that there's a fan, like there's an AC fan, my HVAC fan on the roof for everyone's HVAC fans. and I like was trying to fix it one day. It stopped working. Ultimately, it was a capacitor. I couldn't replace a capacitor, and that solved it. But to do that, I turned off the power, and I found it was 240-volt power, and I realized the building's not going to pay for that. I have to pay for that, which is fine. But that means it's wired to my unit, to my circuit breaker, actually, like right there. So I realized I have physical conductors going to the roof. So I can now use something called power line, and I put my internet or my IP over the power going up, and then I split it off. So I have the 240 volts that goes from my circuit breaker all the way up, and I have a power line device where I connect Ethernet, and I put IP over the 240 volts. And then I have another power line device, and that splits the power from the IP. And now I have a switch and some Raspberry Pis and some other computers and software-defined radios all on the roof and LoRaWAN transceivers. So I have basically gigabit networking, which is just a really neat way of doing it. Before I was bouncing Wi-Fi off my neighbor's building, but
you must have the best Wi-Fi around. That's incredible. I love this. So I want to keep going, but we're limited to like an hour. Final thoughts. You said earlier, I love this about security. A general idea with security is like, and electronics in general, being to keep it as low tech as you can. And I'm curious how you're applying that to OpenPath. So obviously you've done the thing where like the reader itself is not a smart device; it just like channels everything through, and that's kind of like an embodiment of this ethos. I'm wondering what else you do at the company that, or in your personal projects. How can people use this idea to make their devices more secure that they're building?
Yeah, I mean, security is hard. And so, I mean, I love tech, right? I love actually complex systems and a challenge. So I do want things to, I do want to find, but if I can find a simple solution to do something really cool, then that's actually great. I'm not sure if I have maybe a good list or anything, but I would say, I don't know. I think it's over time, like learning how attacks work, like where are the weak points, and where, nothing's gonna be perfect. But yeah, I know the reader, if that's on the wall, anyone has access to that. So that is a weak point, right? Someone can modify that. So I should just assume, and I definitely try to think of the future, not what works today. Like really, you want to, I don't know, this expression, I think it was like skate to the puck, or like where the puck will be. And right, I want to think, where will something be in 5 years?
Yeah.
And I think over time, I'm 36 now. When I was younger, I was thinking, what'll be really cool this year? What'll be really cool next year? Now I'm thinking, what can I do in 5 or 10 years? Because hopefully I'll still be alive in 5 or 10 years. And if I invest my time now into something that will be really cool, then it's much a big payoff. I don't mean monetarily, I just mean enjoyment and like the project. And it's really exciting to like complete challenging things. But yeah, to answer your question, how to keep things low tech, maybe I'll just answer something else as an aside. Yeah, which is one thing I've learned is validate things, like validate how things work, test them. Not that you shouldn't trust people, but people make errors. I make errors, right? I make errors all the time. So I think I find a lot of really interesting things when I test how something works, even if I think I know how it works, right? I know how, with the remote control, with the garage, I didn't know how that worked. And I learned RF and I learned some stuff there. But something like a remote control for a TV that's infrared, I think I know how that works. I have a pretty good idea, even though maybe I've never done it. I've read about it. And then I'm like, I started testing it, and I was like, well, maybe I should make my own IR transmitter for my TV. And I made my own remote. And I knew that from like reading everything that there's a filter, that there's like some 38 kilohertz modulation scheme, and then it's encoding data on top of that 38 kilohertz. And everything says 38 kilohertz, so I think it's 38. And then I realized, I was like, well, I started testing, is it actually 38 kilohertz? And I tested at like 20 and it still worked. And I tested at 10 and it still worked. And then I realized, I can make a remote control without any power. So I just laser cut a circle. And that just had slits. And then I laser cut another circle on top of it. And that had the encoding of the thing I wanted to do, which was power on or off. And then I have an IR light. You can use something that produces IR, like a lamp,
use the sun,
a candle, or the sun, correct? and it's and I rotate it, and I can't get it to 38 kilohertz, but I can get it to 10 kilohertz. And apparently, the way I learned later on that the IR sensors that we use, they have a filter inside. It's not some perfect filter waiting for 38 kilohertz. It's just much cheaper to use a 10 kilohertz high pass filter,
Right.
and so it just rejects other noise like the sun, unless it's coming in and out at a frequency or higher. And then I found I could actually make a mechanical, like a mechanical remote control, which totally useless, but it's just funny.
Have you shared this anywhere?
I haven't shared it. No, I should like post it up.
I can't wait.
Make
That's
it look
amazing.
prettier.
I love it. And since we're wrapping up here, you do have this incredible. Well, it's a really cool looking website. Like, look at these. It's
Thanks.
set up like a desktop with icons. I love it. You've got some non-electronic things as well. Really cool. It's like playing with light and physics and using a physical diffraction and grading to make this beautiful tempered chocolate that says rainbows. And also that mag spoof project. Also, we didn't get around to this even, but like this floating helium balloon network that are all talking to each other. Love it. All kinds of just different stuff. And then also each of those has its own like project page and stuff. Plus there's Openpath, and people can follow you on Twitter and stuff if they want to see more about this. I love this. I knew that you were a badass, but I didn't. There's just so much there that I feel like now I need to spend like hours just like digging into all this stuff that you shared, because it's amazing. Thank you so much for joining.
Yeah, thanks so much. It's always fun to chat with you.
Oh my gosh. And thank you everyone for watching. Have an awesome week, and we'll see you next Tuesday at 10 a.m. for another Hackster Café. All right. See you, everyone.
Awesome. Bye.